Hey students, so today what I'm going to show y'all is a website full of simulations that we're going to be using throughout this class and different units that are math and science related, which is perfect for our course in math models. It's pHET interactive simulations. Okay, what I need you to do is I need you to open up a browser. I need you to go to this URL. It's going to be phet.colorado.edu, and then this window should come up. And it's going to say interactive simulations for science and math, and I want you to click on play with simulations. So when you click on this, what you'll see on the left hand side is a column with quite a few different subject areas that have simulations for them. A lot of these subject areas are things that are actually covered in our math models course. So this is a website that we're going to be using quite often in this class. We're going to be experimenting with simulations in a variety of these subjects. But for today, what we're going to focus in on is we're going to focus in on projectile motion, since this is a topic that we've actually been discussing quite a bit in this class, and I think this would be a good thing to start off with. So when you click on that projectile motion simulation, you'll get this window that comes up. It'll say projectile motion. It looks like a YouTube video that you would click play on. We're going to click that play icon. And then it's going to launch the simulation, and you'll get this window that comes up. And the only thing that I really want you to focus on for this lesson is the introduction. So we're going to click on intro, and what you get is you get the simulation that comes up for projectile motion cannon. And so what your task is going to be with the simulation is it's going to be on how to use this projectile motion cannon to gather data and test hypotheses. I'm going to give you a brief overview of how to use some of its features, and then I want you to experiment and play around with the simulation to test the hypotheses that you make. And the objective of the simulation is to try and predict how varying initial conditions can affect a projectile's path. Things I'm going to want you to look at are the height of the cannon. So if you notice the cannon's on a pedestal, if I click on the pedestal, I can drag it up and down, and that will affect potentially the horizontal range that our projectile will go when we fire something from it. So if I click on this button right here, this will actually launch a projectile out of the cannon. What was that projectile? Well, that projectile happened to be a pumpkin with a mass of 5 kilograms. There's a drop-down menu here. If I click on this drop-down menu, we've got a whole list of different options that we can shoot out of the cannon. So we've got piano. If I click on piano, if you notice, the mass is 400 kilograms and the diameter is 2.2 meters. Now, that's definitely different than what we had for the pumpkin, which had a mass of 5 kilograms and a diameter of 0.37 meters. So, questions you might ask is, well, if I shoot an object with a greater mass and a different diameter than another one, than the pumpkin per se, is it going to go the same distance? Is it going to go further? Is it going to go shorter? That's something that you need to be thinking about. Another thing that you can mess around with is the air resistance here. If I click on air resistance, there's a drag coefficient, and that's going to be 0.6. Okay, so what is air resistance going to do to a projectile? Is it going to have it go further, less far? This is something that you're going to want to be thinking about. The whole point in this is to gather data and to try and come up with ideas and test them. All right, and so other features we've got are velocity vectors. You can click on these, and what it will do is it will give you a vector when you shoot your cannon for velocity. We've got component vectors. We can deselect that, and then we can select acceleration vectors. We can fire that, and then it'll give you an acceleration vector. And then we can also zoom in and out by clicking on these in case you wind up shooting an object that's further than the window that you're looking at. Another cool thing that we've got is we've got this tape measure here. We can click on it and we can drag out to a particular distance if we want to measure, let's say, how far a particular projectile that we launched went. And then what I want you to do is I want you to experiment with this. I want you to experiment with trying to hit this target from different heights of the pedestal that the cannon's on, from different angles that you shoot it from. And then what I want you to do is I want you to try and figure out What is the optimal angle to fire a projectile from the cannon for it to achieve the maximum horizontal distance? Okay, so I want you to play around with this, see if you can figure that out, and then we're going to talk about this during the next class. So that pretty much sums up the screencast, and we'll talk about this when I see you next.